Recall that our problem is to fill out a giant matrix using only a tiny fraction of its entries. In the case of the Netflix price dataset, each row corresponds to a user and each column corresponds to a movie. Here's Frank, and here are the movies that Frank rated. Here's the movie Dirty Dancing that Frank rated 5. In the previous video, Devavrat showed us a method to rank items or movies from noisy observations of their ratings or scores. One of the crucial assumptions that he made was that there was only one single score for each item and therefore one single ranking. Assume, for example, that the 500,000 users in the Netflix dataset are all of the same type as Frank, so let's call them Frank 1, Frank 2, Frank 3, etc. They would give the following ratings for the movie Pulp Fiction, say. Frank 1 would rate it a 4, Frank 2 would also rate it a 4, Frank 3 would rate it a 5, Frank 4 would rate it a 3, etc. So rather than thinking about all these Franks, we might as well think about average Frank, whose rating is 4 plus 4 plus 5 plus 3, etc., divided by the total number of Franks, which is 500,000. This gives the average score for the Franks, say 4.1. So we could then fill out all the missing entries for the movie Pulp Fiction by entering 4.1 for all users, and this would be good if all users had essentially the same opinion of Pulp Fiction, apart from small fluctuations. This approach might be good enough for Yelp. After all, we're all comfortable with the idea that there's a universal scale of good food, and culinary guides such as the Michelin Guide or Zagat are built on this very premise. More generally, we live in a society that's obsessed with rankings, and the very notions of top 100 places to live or top 10 party schools implicitly assume that everyone has the same preferences in these matters. Of course, these notions are very subjective, and this is where personalization enters the picture. Believe me when I tell you that my preferences are very different from Frank's preferences. I don't like Dirty Dancing. I'm more of a Jerry Maguire fan myself. But if anyone asks, I'm into action movies. I like my Bourne trilogy. Now, let's assume that Netflix has only two types of users. All of them are versions of Frank who love Dirty Dancing and hate the Bourne identity. And the other half are versions of me who have exactly opposite movie tastes. If there are only action movies or chick flicks, then the full matrix would now look like this. Here, the matrix has been color-coded for better visualization. A darker color means a higher rating. With the extra fluctuations that account for small variability among users of movies, it would look more like this. The low ratings would be a bunch of numbers closer to 1, and the high ratings would be a bunch of numbers closer to 5. This picture is somewhat misleading though. You get such a matrix when the first rows correspond to users similar to Frank and the first columns corresponds to action movies. In reality, the rows and columns are in a scrambled order, and even in the simple case, two types of users, Frank and me, two types of movies, chick flick and action, the picture is much more complicated and looks more like this. This picture actually represents the matrix that we're trying to reconstruct, but remember that we don't observe most of the ratings. There are only 1.2% of the entries of the Netflix matrix that are known. And what we actually have to work with is this. In this matrix, white means that we do not observe the entry. From this mostly empty matrix, our goal is to recover the original checkerboard pattern. Good luck with that. It turns out that a technique called collaborative filtering allows us to solve this problem using a basic machine learning method called nearest neighbors.